Okay, let's unpack this. You ever, hit a real snag with software where it just behaves, well, weirdly?
Oh, definitely.
It works perfectly fine most of the time, you know? But then you try one specific thing, maybe it's a different browser, or
Yeah.
a strange character in a field, or using it while another app is running, and suddenly PFFT, chaos.
Yeah.
You found some glitch that wasn't obvious at all.
That moment, yeah, uncovering the unexpected behavior, it's incredibly common with software. It can seem totally solid until you interact with it in just the right or maybe the wrong way.
Exactly. And understanding why that happens,
Yeah.
and how experts deliberately try to make it happen, that's why what we're digging into today is so important. We're exploring how software gets tested while it's actually running. It's this thing called dynamic testing.
Right. And our deep dive today, it draws insights directly from a pretty comprehensive guide on dynamic software testing that you shared earlier. Our goal really is to cut through maybe some of the technical jargon and really get to the core of what dynamic testing is, why it's frankly non-negotiable for the software we all rely on, and
Right.
sort of uncover the different ways professionals approach finding those hidden issues by actually seeing the software in action.
So think of our mission today as distilling the essential knowledge from this material. We're going to try and understand how this active form of testing ensures the software you use is stable, predictable, and secure when you're actually using it.
So let's dive right into the heart of it then. At its core, dynamic testing is really all about validating the software's behavior when you execute it.
Okay.
You actually have to run the code, put it in motion to see what happens.
That in-motion part seems key. The material highlights that software testing generally involves two main perspectives. Looking at the blueprint, right? That's verification, often done with static testing without running the code.
Right, like proofreading.
And then checking if the built thing actually works as intended. That's validation, and that's where dynamic testing comes right in.
Exactly right. Static testing is like proofreading that document or reviewing architectural plans before you build. Dynamic testing is like actually using the finished building. You're walking through it, turning on the lights, checking the plumbing. You're interacting with the live system.
The material we looked at gives a simple but I think powerful example, just a login field. If it's designed for, say, alphanumeric characters, entering something like TickUser1 should work fine, dynamically speaking.
Should do, yeah.
But if you then input something like TechUser at day,
Yeah.
and the system reacts with an error message or some other weird behavior, well, that dynamic interaction just revealed something about how the code handles specific inputs while running.
Yeah.
You put something in, the system ran its process, and you seen the result. You saw it happen.
And what's particularly interesting about this validation process is that you're deliberately providing inputs and interacting with the application, but with the specific intent of comparing its actual response to what you expect it to do.
So you're not just clicking around randomly.
No. You're using the software like a user, maybe, but with a detective's mindset,
Right. So it's not just casual use, it's systematic exploration under various conditions, making sure the application consistently behaves the way it's supposed to across different environments. It's about making sure you end up with not just a working piece of software, but the right software that actually meets its goals.
And why is this active validation so incredibly crucial?
Well, the material really emphasizes that dynamic tests are the primary way to confirm the software functions correctly after it's been built and installed.
Okay.
It's your main defense, really, against major flaws in the user experience. Of course, look, no software is perfect. The point isn't to prove the absence of errors.
Right. You can't prove a negative like that.
Exactly.
Yeah.
But it's to aggressively find the ones that are there. Okay, so one of the major things this kind of testing helps nail down is consistency. The guide uses the scenario of a banking app. You might see your account balance displayed in multiple places, maybe on the main dashboard, in a funds transfer screen, or bill pay. If the core balance is, say, $25,000, dynamic testing would check if it appears as $25,000, maybe 25,000, or perhaps even 25K across those different sections. The value might be the same, but the presentation, that needs to be consistent according to the design.
And that consistency check, it goes beyond just numerical formats. The material points out that it covers things like performance levels, how usable the interface feels, compatibility across different devices or browsers, and, much more.
Wow, okay.
Dynamic testing is pretty essential for validating all these different facets of the user experience.
Okay, so we get it. Dynamic testing is about seeing the software in action and why that's vital for catching those real-world issues. How do testers actually apply this? The guide breaks down the common approaches into two big buckets: white box testing and black box testing.
Right. So in white box testing, the testers are looking inside the software. They have knowledge of the internal code structure, the algorithms, the design.
Gotcha. They can see the gears turning.
Exactly. They're essentially testing with transparency. The focus here is often on how the code itself performs and whether its internal logic is sound while it's running. This is frequently done by developers themselves or testers with coding expertise.
Okay, makes sense. Then you have black box testing, which is, I guess, the opposite.
The complete opposite, yeah. The internal workings are treated like a complete mystery. The code, the design details, totally unknown to the tester.
So they're only interacting with the software through its inputs and observing the outputs, just like a typical end user would.
Precisely.
The main goal is purely to verify that the functions of the system work according to the requirements, without needing to know how they work internally.
Mm-hmm.
This sounds like it's typically performed by dedicated testers, maybe, who run systematic tests based on the application specifications.
That's generally right. And black box testing itself is further categorized. You've got functional testing and non-functional testing.
Okay, functional testing.
Yeah.
That sounds like verifying that specific features do exactly what they're supposed to do.
Come on.
You feed it inputs based on the requirements and check if the output is correct. Simple as that.
Well, conceptually simple, but it happens at different levels, building up in complexity. The material highlights the key dynamic functional levels.
Okay.
First, unit testing. Testing the smallest pieces of code, like individual functions or methods, in isolation. This is usually the first dynamic testing developers do themselves.
Right, the building blocks.
Then integration testing. Once the units seem okay, you test how they interact when you combine them. This checks the connections, the interfaces between them.
Makes sense.
Then system testing. Now you're testing the entire application as a whole integrated system to ensure it meets all the overall requirements. This happens when everything is put together.
The whole shebang.
Pretty much. And finally, acceptance testing. This is the final validation step, often done by the intended users or clients, to confirm the system meets the business needs and is, ready for prime time.
That progression makes perfect sense.
Yeah.
You're building confidence from the tiniest code bits all the way up to the complete system the user will actually experience.
Exactly.
Now, non-functional testing. This is where you test the qualities of the software beyond just whether the buttons work, like how well it works.
Precisely. It's less about what the software does and more about how well or under what conditions it does it.
Okay.
This includes things like its speed, how secure it is, how easy it is to use, and how it handles, say, many users at once.
The guide we looked at lists some important non-functional techniques that are applied dynamically. Performance testing, for instance. Yeah. That checks if the application responds quickly enough under normal or maybe heavy usage loads.
Correct. Then you have things like recovery testing, which verifies how gracefully the system recovers if it crashes or encounters hardware issues.
Oh, important.
Very. Compatibility testing ensures it works correctly across the multitude of environments users might have, different browsers, operating systems, mobile devices. It's a huge matrix sometimes.
Yeah, I can imagine. And security testing, which is absolutely critical today.
Yeah.
That involves dynamically probing the running application, trying to break in, essentially.
Basically, yeah. Ensuring it's resistant to unauthorized access or malicious attacks. Probing for vulnerabilities while it's live.
Okay.
And finally, usability testing. This often involves real users interacting with the software to evaluate how intuitive, efficient, and frankly, comfortable it is to navigate and use.
Right, the feel of it.
Exactly.
So, okay, dynamic testing is this broad umbrella. It covers approaches like white box, testing with internal knowledge, and black box, testing purely from the outside, with black box splitting into functional, like does it do the thing, and non-functional, how well does it do the thing.
Good summary.
Through various levels like unit, integration, system, acceptance, and techniques like performance, security, usability testing. Phew. How does all this fit into the typical process of actually building software?
Well, the material describes this as fitting into the software testing lifecycle, or STLC.
STLC, yeah.
Dynamic testing tasks, everything from planning what to test and designing the specific steps to actually running those tests, setting up the right environment, and reporting any issues found. They're all interconnected parts of this cycle.
It sounds like a very deliberate, structured process,
Yeah,
not just random poking.
definitely not random.
The guide points out that the active dynamic testing execution phase really kicks off after a test strategy is defined and the test cases are designed.
Yes, absolutely. That strategy would map out things like resources, timelines, objectives, what's in scope, what's out of scope, potential risks.
The groundwork.
Exactly. Once that plan is solid, then testers design the specific test cases, identifying features to test, setting up preconditions, deciding on coverage, and writing the step-by-step instructions and, crucially, the expected outcomes.
Right, what should happen?
Then comes setting up the test environment, getting it as close as possible to where the software will actually run in the real world.
Like the production environment.
Ideally, yes, or a very close staging environment, installing the specific version of the software being tested, prepping the machines, getting the data ready.
Okay.
And then finally, you execute those planned test cases. This is the real heart of dynamic testing. If the software's actual behavior doesn't match the expected behavior defined back in the test case,
Bingo!
that's a defect or a bug or an issue, whatever you want to call it, which gets logged and reported back to the developers.
Okay, that paints a really clear picture of the steps involved. So what are the big payoffs? Why go through this whole, clearly quite involved process?
Well, a major advantage, according to the material, is that dynamic testing is particularly effective at finding complex or subtle defects. Things that are tough or maybe impossible to spot just by looking at the code or the documentation statically.
Because you're seeing things interact.
Exactly. By running the software end-to-end, you're much more likely to uncover issues related to the interaction between different parts of the system, or maybe timing problems, or resource handling issues like memory leaks. It's really about achieving higher quality from the user's perspective.
And it's emphasized as absolutely essential for identifying security vulnerabilities, right?
Oh, completely. You have to see how the running system responds to various inputs, including potentially malicious ones, to truly understand its security posture. Static analysis helps, but dynamic security testing is critical.
Those are some significant benefits.
Okay.
But there must be trade-offs.
There always are. This rigorous approach, it has downsides. The guide notes that dynamic testing requires actually executing the application, which inherently takes more time than just reviewing static code or requirements.
Yeah, it's an active process. It needs time, people, machines, dedicated resources.
And it can definitely increase project costs, especially if significant issues are discovered late in the development cycle, which, well, can happen with dynamic testing since it often comes after the code is written and integrated.
And fixing problems found later is usually more expensive, isn't it?
Typically, yes. Much more expensive than fixing them during the initial coding phase or even during static reviews.
So it's a balancing act then. It's vital for quality in finding those tricky real-world bugs, but it requires a real investment of time and cost.
Exactly. The conclusion drawn in the material is pretty clear. Static testing provides valuable verification of the plan, the blueprint. But dynamic testing provides essential validation of the reality, the finished product in action. Using both together, static and dynamic, is generally the most effective path to delivering robust software efficiently.
That makes a lot of sense.
Yeah.
Fascinating to see how much actually goes into making software behave, predictably. So just to quickly recap our deep dive here.
Yeah, let's sum up.
Dynamic testing is fundamentally about actively running software, interacting with it under different conditions to validate its actual behavior against what's expected.
Right. It's the validation step that complements static verification.
And it's critical for ensuring the software you use is stable, consistent, and secure when it's in your hands, relying on approaches like white box and black box testing.
Covering both functionality and non-functional qualities like performance.
Through a structured execution process.
Yeah, it's the process of really putting the software through its paces in scenarios that try to mimic real-world use, all designed to reveal the presence of defects that might otherwise just go unnoticed until, well, you find them.
Right. And thinking about this complex process, the planning, the designing test cases, the execution across all these different types of tests, setting up the environments, the sheer time it takes. How might this whole dynamic testing phase influence the overall timeline? And let's be honest, the cost of getting new software updates deployed and actually into your hands as a user?
That's a great question to ponder. And maybe, just maybe, does understanding that the software has been deliberately prodded, poked, and tested in so many ways, does that change how you might think about reporting a bug you encounter? Or even how you frame a suggestion for a new feature, knowing what goes into validating it?
Interesting thought. Definitely something to mull over until our next deep dive.